Hey everybody, this is Larry. This is me doing day 4 of the February Legal Day Challenge. Hit the like button, hit the subscribe button. Oh no. Hit the subscribe button, join me on Discord, let me know what you think about today's farm. When did I do this farm? Why was it? That was like a year ago and it's still in my cache. Alright, let's take a look at the farm that I was trying to not see. 567, permutation in string. Okay, given two string S1 S2, return true if S2 contains a permutation of S1 or false otherwise. In other words, return true if S1's permutations is a substring of S2. Okay. Permutation of a substring. I think the idea here is that I think this is one of those forms that kind of phrase things in a way that are trying to be a little bit misleading in that it was like, oh yeah, just do all the permutation of S1, right? And of course, that would be, a reasonable first start. But of course, the second thing I did is look at the constraints, and then I'm like, well, that's not happening. We're not doing 10 to the 4th or 10,000 factorial, right, for permutation. So, okay. I think the thing to notice is that we can probably do it with sliding window. Yeah, basically in a way, what we want to do is check for every substring, right? So basically, given every substring of length 2, we want to check, is this AB or BA or whatever, one of the permutation. And then we go to the next one. Is this AB? And the next one, and so forth. And of course, in this case, there's only going to be O of n number of substrings. And of course, O of n is definitely way better than n factorial. And if we can check, and the naive way, of course, if you have n substrings and you do n comparisons for each substring, that's going to be n squared or n times m, depending on how you want to say it. But either way, given that they're the same constraint, that's going to be 10 to the 8th or 2 slope. But that's where we get reach the sliding windows, right? We reach the sliding windows because then now we're trying to figure out if there's a way we can take advantage of all the work that we've done previously and then just do a little bit more work and then update the results, right? And basically, for example, you have EI. Instead of going EI and then going ID in comparison, we go, okay, what is the... let me actually ask you on it a little bit here so that's a little bit more understandable. So we go from EI to ID. Instead of just like, treating them as two different things, we can go, okay, well, EI minus E plus D is equal to ID, right? That's basically the idea. And of course, if we're able to do these two operations, I don't know why I mixed them. If we're able to mix these two operations in O of 1 or even log n in theory, but then we're good here. So that's basically the idea. Let's get started. Sliding windows, right? And the way that we can keep track of this is just by having an array of 26 characters or something like that. An array of 26 characters and they count, or you could use a dictionary. Sorry, blanking out here. I just came back from the code. It is very cold here in New York. It is, oh wow, it is 16 degrees Fahrenheit here in New York outside. I don't know what is that in Celsius? -9 degrees Celsius. And actually, that's kind of nuts because people who have been watching this for a little bit, or at least the last couple of weeks, know that I've been kind of playing around with code exposure, and no, I was outside with actually just what I'm wearing now, a t-shirt, except for I not gonna lie, I had a scarf and a very comfortable, like very warm hat, but that's it. So I could feel it. It was cold and there was a lot of wind. So okay, well. So I just came back from there, so I'm like a little bit. That's why if my words are coming up mumbly or jumbly, that's probably why. But anyway, getting back to this, yeah. So we can just I'm gonna do a collection start counter, which is basically maps this into a dictionary, and basically creates a frequency table of the dictionary. So we can kind of take a look here, just to kind of show you. Well, okay, this is not that illustrative, but there's 1A and 1B, and if you look at case 2, oh, I guess that's the same. That's actually not that interesting, but okay. Well, either way, that's basically the idea, right? And then the next thing that we can do is yeah, so we can basically say something like yeah, I mean, there are a couple of ways you can do this. You can count up or count down. That's what I was thinking of. But I'm going to do count up just because it's a little bit easier to visualize. We can do the other thing maybe a little bit later. So basically, the current is the current overlap. And then basically, we go M is equal to length of S2. N is equal to length of S1. I think we only need N maybe. So then now for let's just say index and C and enumerate S2, then what happens, right? Well, we do current of index, whoops. Current of C, we increment by 1. And then if index is, basically if this minus N is greater than 0, that means that then current current of S2 of index minus N, we subtract it back, right? And this is just, basically we split it, like we said, we add the thing that we add to the right, which is the current index, and then if there are N characters, then we subtract, or N plus 1 character in this case, and then we subtract 1 to get an N character again. And then now, if index minus N is I always get this a little bit wrong, but yeah, if index minus 1 is greater than or equal to N, then now we have N characters, right? Because index from 0 to index minus 1 inclusive, that there are N characters in that case. Okay. So if this is the case, if current is equal to count, then we return true. Otherwise, we just return false if it goes through everything. Okay, looks good. Let's give it a submit. Hopefully I don't... Oh, what? Did I mix up S1, S2? Why is this wrong? How did I get this wrong? Don't know how. I mean, the only thing that I can imagine is if there's some weirdness, but okay, fine. Let's see. Actually, kind of sad and disappointed. Let's see. Oh, what was it? A and AB, I think. Huh. It doesn't get here at all. Oh. So index is 0 and then 1. Oh, is this plus 1? Did I mix this up? Yeah. Sorry. Index minus, from 0 to index minus 1 inclusive. So yeah, I mean, I think I just mixed it up. But yeah, really silly mistake. I even thought I had it, but yeah. Let's go submit again. Hopefully this time is right, and it is. The first time I got it wrong. This is what I get for being whatever. But yeah, 1040 streak, yay. Yeah, and basically this is going to be linear time. This is going to be linear time. This comparison is going to be O of 26. There is a way to get this from O of 26 to O of 1. You can also say it's O of alpha for alphabet. The size of the alphabet rather. So then you could say that this is O of n times the size of the alphabet, or alpha, which is 26 times 10 to the 4th, or 260k, which is why I'm like, not worth my time optimizing a little bit. But yeah, if you did get this, see if you can do this in O of n time instead of O of alpha times n times. That's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.